Hi friends, in this video let us solve EMF related problems asked in GATE 1991 ECE paper. So the question is, a uniform plane wave in free space enters into a lossless medium at normal incidence. In the medium its velocity reduces by 50% and in free space it sets up standing wave having reflection coefficient of minus 0.125. Calculate permittivity and permeability of the medium. So what they are telling, uniform plane wave in free space enter into a lossless medium. So this is medium 1, this is medium 2. So this is free space. From here the wave enters into lossless. Okay, right? And wave is propagating like this. Let us assume the wave goes like this. From here to here it is entering. Okay, so what is the permittivity and permeability here? Permeability is mu1, let us assume it is epsilon 1. Here it is mu2 and epsilon 2. This two only we have to find. We have to calculate permittivity and permeability of the medium. Since it is a free space, mu1 is equal to 1, epsilon 1 is equal to 1. Okay. So what they have given? The wave sets up a standing wave with the reflection coefficient minus 0.125. So in medium 1 velocity, we know velocity is given by root of mu naught epsilon naught in free space. Similarly, this medium 1 is free space. In medium 2, velocity is given by root of mu epsilon. Why it is mu naught epsilon naught? Because it is free space. Here root of mu epsilon, that I can write as root of mu naught epsilon naught into root of mu is equal to mu naught mu r, right? So mu naught and mu r I write as mu 2 epsilon 2. So this is second one. Okay, so now if you divide v2 by v1, so this is equation number 1, this is equation number 2. v2 by v1, we know in medium 2 velocity reduces by 50%, that means 1 by 2. So compared to v1, velocity in v2 is 50%, that is 1 by 2. So 1 by 2, so v2 this one, v1 is this one. If you divide, what we get is mu 2 epsilon. Right, so this implies mu 2 epsilon 2 is equal to 2. So mu 2 epsilon 2 is equal to 4. Okay. So the wave is incident normally. Next point we have to note down is it is incident normally. Okay. So wave incidents normally. For normal incidents, we know reflection coefficient is given by eta 2 minus eta 1 divided by eta 2 plus eta 1. So the wave sets up a standing wave with reflection coefficient minus 0.125 as per the problem. Eta 2 we know the relation between eta and mu and epsilon. Eta 2 is mu 2 by epsilon 2 minus mu 1 by epsilon 1 divided by mu 2 divided by epsilon 2 plus mu 1 divided by epsilon 1. So mu 1 epsilon 1 we know it is 1. So if you substitute 1, so mu 2 by epsilon 2 minus 1 divided by mu 2 by epsilon 2 plus 1. Right? So this is plus 1. Then if you simplify left hand side, minus 0.125. Right? So if you bring all the things here, so mu 2 by epsilon 2 minus 1 mu2 by epsilon 2 plus 1 into minus 0.125. What we get is, after simplification, you will get mu2 by epsilon 2 is equal to 0.875 divided by 1.125, right? So this implies if you take root, mu2 by epsilon 2 is 0.6. So we know from this mu2 is equal to 0.6 epsilon 2. We know mu2 epsilon 2 is equal to 4, right? So epsilon 2, we know mu2 is equal to epsilon, mu2 epsilon 2 is equal to 4, already we derived this. Now we got mu2 is equal to 0.6 epsilon 2, right? So what you do, instead of mu2, you substitute here, mu2 is equal to 0.6 e2, so epsilon 2 squared is 4 by 0.6. If you simplify, what you get is epsilon 2 is 2.58. Epsilon 2 is 2.58. Substitute epsilon 2 here, what we get is mu2 is 1.85, right? So this is epsilon 2 mu2. What we need is in epsilon, in medium 2. Epsilon is equal to epsilon naught, epsilon r. So it is epsilon is equal to 2.58 epsilon. This is what epsilon r, relative permittivity. Similarly, mu is equal to 1.85. So this is the answer. What we found is relative permittivity. We know what we don't know the nature of the medium, so simply we put epsilon naught, right? So this is relative permittivity, this permeability, right? So I hope you understand this problem. If you have any doubt, ask me in comment section. Thank you.